Ether hydrolysis. Ethers also react with strong aqueous acid in a reaction analogous to the one that we've covered with halo acids, only in this case, instead of producing alkyl halides, we produce alcohols. Now, in that reaction, we still have the ether playing the role of the electrophile, the oxygen in one side of the ether, initially at least, playing the role of the leaving group. And this will produce a pair of alcohols. See if you can take a moment, given that what we've just said, to draw the alcohol products for this reaction. The products of this reaction will be tert-butyl alcohol as well as cyclopentyl. In terms of mechanism, we're going to start out, instead of using the sulfuric acid, we can use H3O plus as our strong acid. Remember that when you put sulfuric acid and water together, you really don't have sulfuric acid anymore. You have H3O plus and hydrogen sulfate. So initially, our first mechanism step is the same as with the reaction of alkyl halides. We start with protonation as our first step. We create a protonated ether, and this allows us to create a good leaving group. Now, we're under reactions that favor Sn1 conditions, Sn1 and E1 being unimolecular, carbocation is formed. So in this case, with our asymmetric ether, we want to consider which side is going to be the leaving group. Will it be the cyclopentyl, which would leave a tertiary carbocation, or will it be tert-butanol, which would leave a secondary carbocation? Which do you think is better? Tertiary carbocation or the secondary carbocation? Yes, the tertiary is better. And so in our mechanism, we want to draw the oxygen-carbon bond between the tert-butyl group and the oxygen breaking. That will give us our carbocation that's tertiary, and it also gives us our first alcohol product, cyclopentyl. And now to get to the second alcohol product, we have two steps. The first is going to be to use water, the nucleophile, which you can say is produced in that first step, or you can say is simply plentifully available under hydrolysis conditions, where we have water and sulfuric acid. The water acts as a nucleophile. The carbocation is our electrophile. The two combine to give us a protonated alcohol. And I'm going to draw that down here because I ran out of space. Board management happens on the laptop as well, apparently. And this just leaves us one step left, which is to go from the protonated alcohol to the neutral alcohol. So we need something that is a reasonable business acting like a base. Let's say water, to come along and pick up that extra hydrogen. Oxygen lone pair reaches out, grabs the hydrogen, oxygen bond breaks. Whoops, let's draw that from the bond, not from the hydrogen itself. And that will then produce our other alcohol product.